Okay. So today we did a combo lesson. The effects of extremes is what it's called. So basically, what are outliers and how to deal with them. So what is an outlier? Yeah. Okay, so data far from the main group, if you will. Like an outcast, far from others. It could be on one end, it could be on the other end. Can outliers be in the middle? No, so outliers pull the data in one direction, so like how we saw today. We had a bell-shaped data set. But depending on what end the outlier was on. Maybe it was on this end, it did something to like the mean and maybe something to the median. If I have data added to the right of the rest of the data, would I expect the mean to increase or decrease? So numbers to the right on the number line are bigger or smaller. So if I have an outlier on this end, I'd expect the mean to increase. What about if I have it on this end? Would the mean increase or decrease? Decrease, because numbers to the left on a number line are smaller. So that's what we were hoping you could recognize in the warm-up, but when in doubt, just do the math and tell me how things like mean, median, IQR, or standard deviation change. Another key thing that may have not been explicitly said, but that you will need to know, is that if the data is symmetric, whether it's bell-shaped, bimodal, maybe some other random shape, but as long as it's symmetric, what do we prefer to use, the mean or the median? We prefer to use the mean if data is symmetric. If it's skewed, that's when we use the median, because like we said, outliers might be a bad representation of what's going on. So like if I took a survey of all of our ages in here, and I added my age, because what, you guys were what, 14, 15? And I'm 26. I would be the outlier, right? Should I include myself in the data when I'm talking about the ages in my classroom? No, because why would there be a 26-year-old? Like, obviously that would be the teacher, we would exclude that. Okay, so that's what we were talking about. That's where like the median would be better than the mean if the data is skewed, if there's an outlier. If you didn't quite understand that, you'll see it in the next lesson, so hopefully that makes more sense soon. The other stuff, how to know if something's an outlier. What's like the rule we learned? The mathematical thing we learned if something's an outlier. Yes. Okay, good. So depending on whether you're looking at like a small data point or a big data point, it's always 1.5 times the IQR and then whatever quartile it's closest to. So if I want to see if something's an outlier on the smaller end, then I would do Q1 minus 1.5 times the IQR. And then anything below that would be an outlier. Anything on this end, the right side of the data that I want to test, what quartile is closest to the maximum? So I would do the Q3 formula plus 1.5 IQR. I know that might not be that easy to memorize. That might be like one of the few that you would have to memorize for this unit. But most of the time you can kind of guess if something's an outlier. So most of the time you may be right, but that's how you can mathematically prove it. So there's that. Any questions? That's like our recap of the lesson, seeing if you understood it or not, you can answer all those things. I want to leave this up for at least a while, so I'll just tell you the practice for today was two separate ones, but they're both needing to be at 80% or higher, so. They're both short. They're both. Should you finish that early, all the other practices should be done up to this point, and not do them. Make sure your binder is in order, not necessarily in order, but like done. So we have a binder check next Friday. What else? The box plot foldable, more of them were graded, so I'm gonna pass that back. Want to review that, or if you never turned it in to begin with, that's something you could use past time today to do as well. Yes. Yeah, the binder check is me checking that you took notes on the parts you took notes on. Yes. Yes. Any other questions? All right, so feel free, if you work through the practice and have a question, call me over. Otherwise, I always check in like the last 20 minutes or so to make sure. But, yeah, this is your hours to focus on math primarily, but also get your other stuff done. Again, we are on lesson 10, number 1. We just barely touched on this today. So when might you want to use the middle number of your entire data set versus the average? Like, don't tell me the answer, but tell me like, when might it be better to use the middle number versus the average? What did we mainly talk about today? Okay, so when there are outliers, basically when the data is skewed in one direction, maybe they're not outliers, but it's skewed in one direction. Basically, when the data is not symmetric, then you're better off using the median, because any outliers will pull the data in one direction that might not be representative of what's actually going on. So symmetric is obviously symmetric. We're not going to pick that one. Bell-shaped, is that symmetric? So for things that are symmetric, I'd rather use the mean, not the median, so don't pick that. Skewed is when we prefer to use the median. Data that is uniform, would that be symmetric? Yeah, so if I have all of my data is one number, that's an example of uniform. If all my data is just like at the same level for all the numbers, that's an example of uniform. So it would be symmetric, so we wouldn't use the median over the mean. Make sense? So anything that is skewed or not symmetric, we prefer to use the median over the mean. Questions on that? Questions on others? Remember, it can be any practice, anything. Yes. Alina, correct, that one. How does it start? All right. So Diane took a survey of students in her class to find out how many hours they spend reading each week. Here's summary statistics for the data she gathered. So they didn't make you type it all up. They're actually not even showing you the data. They're just providing you the summary statistics. It says, which is an example of a number of hours larger than the median, which would be an outlier. So my median is 7. That means my middle number is 7. And we're examining 15 and 22. So we're gonna use the IQR rule to mathematically prove, but like using your critical thinking skills, which one is probably more likely an outlier? And if 15 an outlier, then 22 would also have to be an outlier, right? So critical thinking skills would tell me it's gonna be 22, but I'll show you with the rule 2 in a second. And then it says, are there any outliers below the median? So. Do I have an- I don't know. We'll see. Oh, because you're in my quarter one, maybe, we'll see. So the rule for determining if something is an outlier is 1.5 times the IQR. And then it depends whether or not we're looking at an outlier above the rest of the data or below the rest of the data. So since we're looking for a number that's bigger than the median, we'd probably rather use this one, which would be my quartile 3 plus 1.5 times my IQR. What's the formula for IQR? Okay, good. So I'm gonna put that in here. My Q3 is 11 minus my Q1 is 5. Please use the calculator for this part. Let it do the order of operations for you. I'm just gonna do it by hand real quick. So 11 minus 5 is 6. 1.5 times 6, I want to say is 18, but I will check. It's 9 actually, so see that's why I always check. Right? Okay, 1.5 times 6 is 9. Plus 11 is 20. So anything that is above 20 is an outlier. So yes, for sure, 22 is an outlier. And then are there any outliers below the median? Well, I just don't see the data, so that's kind of hard to tell. I'm gonna go with no. I'm missing some key element here. I'm gonna also check in the book, see like if there's something else we're missing here. But I don't see the raw data, I just see the summary statistics. None of this tells me what my data is. It doesn't even tell me my minimum. So I don't think there's enough information to tell if there's any outliers on the lower end. I will check and then I'll confirm with you, but the key says no. Or actually, maybe there's a reason why. Okay, so if we're checking data on the lower end, if it's an outlier, that's where you use this one. So if my quartile 1 is 5, and my IQR was 6, by the way, so we're doing 5 minus 9. What's 5 minus 9? Probably negative. Okay, so that's why we actually do have enough information to say no for sure. Because anything below -4 is an outlier. And if the data is supposed to be how many hours people spend reading, can people read -4 hours? So that's why we can confidently say no. We've got enough information. Questions on that? Okay, questions on others? Yes. Okay, an outlier on a box plot. Was there an example, do you remember? Okay. Well, from a box plot, it's still the same rule. It has to be like 1.5 times greater or less than the IQR. So let me just sketch a little box plot up here. So on your box plots, you're supposed to be able to see 5 different values. Remember our 5-number summary for box plots? Okay, maximum would go here, minimum over here. What else is on a box plot? Q1 is this edge. My median of the whole thing in the middle. And then Q3 is this edge of the box. So since when determining if something's an outlier, we are doing 1.5 times the IQR, you should be able to, on your number line, see what your Q3 and Q1 are. So like, I don't know, say it was, in this case, 11 and 5 for the quartiles. Well, then that's telling me my IQR is 6, so 1.5 times 6, 9, like it can't be above 1.5 times the IQR in this direction, so 11 plus 9 is 20. And then it can't be 1.5 times the IQR below in that direction, so like 5 minus 9 is -4, so that's like the cutoff. Does that help? Okay. Sure. Other questions? Okay. Good conversation. I remember seeing this come up on the final, but like, when in doubt, you can probably get it right if you just know like outliers apart from the rest of the data. But the mathematical way to prove it is with that 1.5 times the IQR. But any other questions at all right now? Think of any, don't be shy, we still have time.